Hey, this is Workbench with Workbench Quagmire, back with day 76 of our free code camp Python certification in 100-ish days. And today we are going to undertake the implement the bisection method workshop. So let's just get right into this. So the bisection method is a binary search method, uses a binary search to find the roots of a real valued function. It works by narrowing down an interval where the square root lies until it converges to a variable value within a specified tolerance. For example, if the tolerance is 0.01, the bisection method will keep having the interval until the difference between the upper and lower bounds. This is going to become important, and for those of you who are watching this video because you got stuck, this is important. The difference between the upper and lower bounds is less than or equal to 0.01, not the difference between the actual square root and your calculated square root. If you go to the question section, you see a lot of that. So, and I had that problem too the first time I built it. I built it differently. So, in this lab, you will implement a function that uses the bisection method to find the square root of a number. Here's our objectives, our user stories. You should define a function named square root. Default value for the tolerance and maximum. Okay. Tolerance will be acceptable error within the margin. You should set a default tolerance value, maximum number of iterations to perform. You should set a default number of iterations. So we'll just make this 10, which will end up being low compared to our tests, and our tolerance we'll set to what they had, which is 0.01. And then you can see here the next test we fail is the square root function should raise a value error with the message square root of a negative is not a real defined number or real number. So this is in our user story 2. Raise a value error, and then the next one is for numbers 0 and 1, square root. We should have a message there too. So got a couple of if statements here. If num is less than 0, should raise a value error with the message go. And then if num in 0 or 1, in this case we want to print this message and return the number itself. So print. Okay, let's do this one here. So I'll show you what we're gonna do here, but if none of this stuff happens, then basically we haven't found our number. So then this last user story becomes relevant. We want to print this and return none. Okay, so then this first thing here will be up here. So when we need to iterate. There's literally iteration in this thing. So for any positive number, print the approximate square root with the message this, and I'll just go ahead and put that in here. It's going to be inside a for loop. So one of the things I've seen people do is, you know, you're going to have, remember the bisection where basically you have a low limit and a high limit. You average them. That becomes your first guess. If your guess is low, then you make the mid like 1 plus if it's an integer, or you make the mid the low limit, and then you find this point in between the low limit and the high limit again. Guess that. If it's too high, then you make the midpoint the high lit, and then you find, you know, you just repeat this. You iterate over and over and over again. And I think I've said this a couple of times, while loops are dangerous. If you try to implement this with a while loop, you're going to have a lot of problems. Your little browser things are going to spinny and stuff like that, because just as you start writing it, if you don't have a way to exit that while loop, it'll immediately create an infinite loop. So in this case, we have this max iteration. So we know that we only want to run it for a certain number of iterations. So we don't need a while loop where we just run it infinitely until a condition's met. We're going to run it 10 times, 50 times, 50 times in this case. So we're going to start with a for loop. For I in range max iter. All right. And before we get in there, now we need our high and low. So our low limit, let's say we have any number, and it has to be positive or 0. So our low limit would be 0. It would be, you know, if we use 1, we'll get 1. If we get something between 0 and 1, it'll still be 0, because it'll still be the lowest number. And our high number would be, say, 0.3. So our upper, let's just put that in here, low equals 0. Upper is going to be the minimum or the maximum of 0, the actually maximum of the number or 1. And the reason that is because you don't want your maximum to be your square root of a number less than 1 is greater than the number, right? So you don't want to have a situation where your first guess is 0.5 and you say, well, no, that's too high. You know, it just won't work. So our high limit is going to be the max of 1 or our number. And then once we get into our for statement here, we'll calculate our root. So our root will be, this is going to be our guess. It's going to be low plus high divided by 2. So now we need to do a check and say if, now this check, remember, go back here to, we're checking if the tolerance is, if we've met the tolerance between the intervals between the upper and lower bounds. So that's what we're going to check here. So we're going to say high minus low less than tolerance. Then what does our user story say? For any positive number, print the square root, print this message. There we go. Actually, I'm backing up. So For a positive number, print the approximate square root with the message and return the computed root value. So there we go. So if our tolerance, if our low and high become close enough, then that's close enough to where our square root is. We print this. Now, if, we'll say else, elif, trying to remember how I did this. I think it said if root times root is greater than num, then then I believe our high equals root, else low equals root. See where we go. Oh, that was it. Okay, let's go back. I can't believe I nailed that on the first. Oh, now I can't see it. So frustrating. But that was it. So basically, you implement that algorithm from the binary search. But yeah, that actually went way faster than I thought it was going to be. But the key is don't use a while loop. Make sure you're checking for the tolerance between the high and low bound, and not between the actual square root, which you can find without using the math function, which is one of the things in there it says not to do, and what your calculated square root is. And just make sure you're adjusting those bounds based on where you land. So that was fast. So thanks for watching the video. Don't forget to comment, like, and subscribe. And tomorrow we will do the implement merge sort algorithm workshop. See you then.